Please welcome Randy to S4 Stage 2.
So today I'd like to talk to you about OPC UA and how it is a protocol that is uniquely suited for connecting ICS applications to the cloud. I take the position that the best way to ensure security is to have a protocol that is dedicated to the needs of industrial applications. But OPC UA goes beyond that because it also allows you to take advantage of things like TLS when it's appropriate. And I'll be talking quite a bit more about how all these different parts can fit together. I want to start by talking about where OPC fits, at least it has fit traditionally. It's been around for, OPC itself has been around for almost 25 years now. It is the standard for connectivity between SCADA and devices on the factory floor. Virtually every factory in the world has some level of OPC installed in it. About 10 years ago, the OPC Foundation decided to work on the next generation of OPC, which was called OPC UA. And we took all the experience that we had gained from our Windows-centric solution, which had worked very well, but the world was changing and the cloud was coming on the horizon. People had a much broader vision in terms of what they wanted to accomplish with their industrial networks. And we wanted OPC UA to be the foundation that would allow factory owners to move forward to that new world. And so we pulled in all these different requirements to try and come together with a cohesive standard that ends up having a lot of features that really work well for IoT applications. The first one, and I can't emphasize this particular one more, is security. When we built the OPC UA specification, security has always been the first thing we talk about. It's like, how do we secure this? Not only how do we secure this, how do customers and vendors, how do they manage security? Because it's easy to say that you're going to encrypt all your traffic, but then leave it to the end users to figure out how to actually configure this stuff. That wasn't good enough for us. And so we have entire parts of the specification that are dedicated to managing security. And you won't see that with other protocols. We also needed mechanisms for migrating over time as needs change. And so we started off with some profiles which made sense 8 years ago, but now they don't. So we needed a way to migrate users over time to the to new profiles. And the ones that we just recently depreciated were the SHA-1 profiles, which most of you are probably familiar with, is no longer an algorithm that we want to use, even though there's no specific exploits. And we do this with the strategy. One, we have the profiles in terms of saying, well, here's a finite set of algorithms everybody has to support to maximize interoperability. And the second thing is we provide open source stacks that implement all of the profiles that we allow. So what that means is that when we release new profiles to meet new requirements, anybody who's got an existing OPC application can simply grab the new stack, incorporate it into their application, and do whatever testing and validation that they need to do. This process is really no different than what a lot of people already are doing if they go and grab OpenSSL. And that having that open source code base is essential to making OPC UA a viable technology. The other aspect that makes OPC UA great for IoT is interoperability. Interoperability and plug and play between different vendors has always been what OPC is good at. It came into play because people wanted to be able to plug in an HMI and have it talk to any device on the factory floor without having to write a custom driver for every device. And OPC UA continues that tradition. And we ensure that capability through a specification development process which focuses on implementation, making sure that we can implement everything in the specification before we release it, and a compliance program where we have tools which vendors can use to verify their applications to make sure that they actually comply with the specification. And we have a number of test labs that we're opening up around the world to allow vendors to take in their applications and get them certified. And we have a logo program, so vendors who do get certified can advertise the fact that it's certified. And factory owners can now turn around and say, well, hold it. If I'm going to deploy UA software in my factory, I want to make sure that I've got certified UA software. And all of these different pieces together add up to interoperability, which is lower cost of ownership. Adaptability. One of the things that we did with UA is make sure we have a very clear layered architecture. So at the top level, applications are built against an API. And it doesn't even talk about the transport. There's no details of the transport leaking into that API at all. Below that, in the stacks, we have the different transports. And what this means is that we can drop in different transports to meet the needs of different applications in different contexts. And that's what a lot of this talk is going to be about, talking about how we can put in different transports to meet different use cases needed for IoT applications. And these things are in addition to the workhorse, which is SCADA talking to devices over a LAN, which is 90% of where OPC UA is going to be used. In addition to transports, we also offer variations in encodings, because binary is great when you've got UA applications on both sides because it's fast and it's efficient. But there's lots of situations, especially with IoT, where you want to put stuff into the cloud, where you've got these generic analysis engines that don't necessarily want to deal with an industrial ICS binary format. They would rather get XML or JSON. So OPC UA has the ability to take the data that is serialized in binary, but now serialize it in JSON or XML. And the open source stacks that are available have serializers that literally have a switch. Say, give me JSON, give me XML, or give me binary. It's an easy to switch between the different encodings. And we've set up the specification to make that easy. And the last thing, which is largely out of scope as far as this particular talk goes, is the rich information modeling framework, which allows you to work with data using terms and concepts that are relevant to the domain you're working with. In UA, you're not dealing with tag values and PLC inputs and outputs. You're dealing with objects that produce events and have variables and have methods. It's everything that you would expect from an object-oriented coding environment, but it's available via an address space which you can browse using standard APIs. And one of the advantages of this information modeling framework for IoT applications is a lot of times you want to take your factory data and you want to get it up to the cloud to do things. But yeah, sure, I just dumped a bunch of sensor values into the cloud. That's really useful. No, what you need is metadata to describe what all those sensor values are, how they relate to you. OPC UA gives you a modeling framework that allows your cloud application, if it needs to go and discover by connecting directly to the server and sort of see what it is, or depending on your connectivity requirements, you can simply save this model into a file that can be uploaded to the cloud application, and this will enable much more sophisticated analysis programs than you would ever get without such a framework. Now, I'm going to get into the details of the actual protocol that allows the kind of flexibility that you need for IoT applications. We have two message exchange patterns: client-server, which is the workhorse. It's used virtually everywhere. It's a simple request with a reply that comes back. The client knows the request was delivered because it either gets the reply or it gets an error code. It's usable. We build all of our standard functions like browse, read, write, subscribe based off these services. However, client-server is not particularly scalable. It requires a point-to-point connection. So you've got 100 clients and 100 servers. All of a sudden, you've got 10,000 independent connections. That starts to become unmanageable pretty quickly. So there are lots of applications, especially when you're getting into the cloud, where you need a different paradigm, and that's where publish-subscribe comes in. With publish-subscribe, you could have publishers or multiple publishers constructing messages that are put onto some sort of transport that delivers it to multiple subscribers. The publishers don't know who the subscribers are, and they don't know if it actually was delivered, and if there's any kind of persistence or guaranteed delivery, that's the responsibility of the middleware. So it could be something like an MQTT broker or UDP multicast. We don't care at this level. So to support those two message exchange patterns, we have two abstract protocols which allow for secure exchange of data over and routed through any number of untrusted intermediaries. And this is what separates OPC UA from solutions that just wrap everything in TLS. Is the messages at the application level are signed and encrypted if you want to. You don't have to encrypt them. And once they've been put into this blob, you can then take that blob and you can put it into anything that can get bytes from A to B. And no matter who touches it in the meantime, the only recipient that will actually be able to understand what that message is the intended recipient. Now, the UA connection protocol is intended for request response, so it uses PKI to negotiate session keys that are used to encrypt and sign all the messages that are exchanged. The certificates that both the client and the server have are used to determine trust, and this is an important part of any industrial control system. You want to make sure that only applications which you are authorized to connect to your device are actually connecting. And this is actually an improvement over previous versions where the interoperability was great, but factory owners had a problem with somebody downloading some VB app and connecting to their OPC server. They didn't want that because they didn't test the VB app. With OPC UA, you could now restrict that. Now, the datagram protocol is the equivalent for the publish-subscribe message exchange pattern. Now, with the publish-subscribe message exchange pattern, there's no negotiation of a session between the client and between the publisher and the subscriber. So you need to have some other mechanism for distributing keys. So we have the security key server, which is some sort of service which is a UA server that supports the client server paradigm. So we take the infrastructure that we've already developed for client server, we use it to distribute keys that are now enable the publish-subscribe process. And again, in the same way, the messages are secured, and they can be delivered over routed through any number of untrusted proxies to get to their ultimate destination. Now, I want to talk a bit about some different use cases that OPC UA supports that are going to be valuable for different kinds of IoT applications. And the important message here is that there's no one-size-fits-all in terms of what one solution will solve everybody's problems. Everybody has slightly different problems, so we have slightly different solutions to address the breadth of it. The first one is a very simple, tunnel everything through HTTPS. This is great when you've got a client that needs to communicate with a server in the cloud. The server would have an HTTPS endpoint. The server doesn't actually have to be in the cloud. You could have some sort of front end, which is doing some reverse proxy stuff to redirect requests to an actual server that's in a factory somewhere. But these are all sorts of network architecture details that an individual factory owner could work out. The specification itself allows for that. HTTPS can be used directly as your only form of encryption and authentication, but you can also apply an additional level of security by encrypting and securing each of the individual messages, so you avoid leaking any data to whatever proxies that might be out there trying to intercept your HTTPS traffic. So that gives you your additional security. You can use different encodings. JSON is an interesting one because when combined with sessionless method calls, the idea of making a single call to make a method call on a UA server, and you have a JSON request, you now have a dead simple web API for OPC UA. All you're doing as a client is crafting a JSON message, posting it to the server, and getting a JSON message back. You don't even need to know anything about UA in order to access that particular API. And what this does is gives you the ability to say, well, hey, I've got this server that's doing lots of things in my factory, but there's certain features I'd like to make available to web clients via web API. So I'm going to make these methods, and I'm going to make them available via an HTTP endpoint. A variation on that uses WebSockets. WebSockets are a popular way to get through firewalls. It's kind of ironic that IT departments are perfectly fine with somebody sending out an HTTP header and then grabbing the socket and using it to send binary data, but have a problem with opening up another port to send binary data. But that's the way the world is. We don't question it. And WebSockets maps nicely onto that. We simply take the messages that we have already defined as part of the abstract protocol, and we stuff them into WebSockets frame, and they get delivered. They can be encrypted and signed as per all of the other mechanisms. It's all the standard framework, and that gives you your end-to-end security. You don't care about proxies or whoever's in the middle. They can save the data. They're not going to be able to understand it. And the next one, of course, is people talk about, oh, you're going to put all your devices on the internet, make the Internet of Things, and they have a lot of this hype that you see in the media. But as soon as you sit down and think about it, oh, I'm going to put my device on the internet, that's going to expose it to all kinds of attacks. So the next thing you say, well, I need a firewall. Well, if you want somebody to access it, you got to open a port in the firewall. And often, your IT department will have a big issue with that. And in fact, a lot of times they'll say, no, we're not opening a port. Then all of a sudden, your dream of having an internet available device kind of just vaporizes because you just can't get it out of the firewall. Well, OPC UA via a WebSockets relay is an option that will allow you to work with that particular architecture. In this case, you have a WebSockets relay that's sitting in the cloud at a place which the server's configured to know about. It connects uses HTTPS, and you get your certificate authentication going there. And it simply advertises the fact that it's available. Meanwhile, a client can come in and say it would like to connect to server 1, and the relay will just be kind of a telephone switch. Copy the data from one incoming socket and push it out to another outgoing socket and back and forth. This data, of course, is completely encrypted. The relay itself can't see it, so there's no security risk there. The relay is a relatively simple application to write. We've been working with partners such as Microsoft, who already have similar relays which they develop for other applications. They're already working hard to incorporate UA right into Azure and their own device hub. I forget what it's called, but they have this framework for managing devices within Azure, and UA is a first-class concept within their framework, and they're working to provide a standard WebSocket relay. At least that's my understanding. And the last one is UA PubSub via any number of relays. So people talk about taking advantage of MQTT or AMQP to get data, to basically distribute it to large numbers of subscribers, distribute it to subscribers in the cloud, to create this nice level of isolation between the two endpoints. And with PubSub, you can do that. You can create these encrypted messages, send them out to the broker will take care of delivering them. And this particular architecture works well. I believe that Bayshore has this one-way firewall. Well, this PubSub mechanism works very nicely with that. So you can deploy these high-security firewalls and still be able to get your data out to the applications that you need to in order to take advantage of any number of cloud services, or simply to get different disparate locations in different geographic locations to coordinate with each other by sending messages to each other via the brokers. So, to summarize, OPC UA works for IoT because of its security model. You have a standard security model that is replicated in various use cases, but the overall framework, how do you manage security? How do you set up the certificates? How do you decide what algorithms are supported? All of that's the same across all these different transports. And you get this degree of commonality between your stuff that's working in the LAN and the stuff that's working across the IoT, and that has a potential for reduced administration costs from the common model. Interoperability. Applications can simultaneously support multiple endpoints that serve different purposes. You can have your SCADA system that's doing all of its stuff talking to the PLCs, but then turn around and expose a WebSockets endpoint that has very restricted capabilities, but it ends up being one application. You don't need to create sort of these gateways and sort of multiple tiers of stuff to do protocol translation. It ends up becoming a single coherent solution. The adaptability is key. I talked about how UA has all these different transports. A lot of these transports didn't exist. In fact, all of them didn't exist when we originally wrote the specification. They only came about because we would be going out and be talking to end users and saying, what do you need? Where are your pain points? What do you think is important? And we said, okay, those particular transports, there seems to be a good business case for them. We will add them into the specification. And the last one, of course, is that the entire concept of moving away from simple tag-based descriptions of data to an object-oriented, rich framework that can fully describe relationships with other data, and that can be layered with other information models to facilitate reuse. That's about all I wanted to say today.
All right. Do we have any questions for Randy?
Andrew Ginter with Waterfall Security. You've touched on a pet peeve of mine. You're talking about secure communications, secure messages, secure envelopes. Yet we all know that nothing is secure. Crypto systems have bugs. Remember Heartbleed. Anyone who can manipulate the certificate authority can compromise encrypted communications. In my experience, anyone who uses secure as an adjective is selling something. You can always be more secure, you can always be less secure. Saying, is this secure, is a question that has no answer. What is the foundation selling here? What are they trying to persuade us of?
Well, we have a protocol that is being implemented by many different vendors that provides the infrastructure you need to create systems that will give you a higher level of assurance that your security requirements will be met. That is, I guess, a more precise description of what we have. I agree with what you're saying, is that there is a tendency to simply use the secure as an adjective without really defining what that means.
One of the questions I actually have is that the title of the presentation is it the bridge to the industrial internet of things? And if you could pick a feature that the OPC Foundation has put together that makes it the bridge, what would that feature be?
I would say that the ability to do the PubSub to the cloud, I think, is the key thing that's sort of come in, because the Internet of Things is many things to different people, but one of the things that I see as being absolutely essential is being able to do massive scaling, like going to hundreds of thousands, if not millions of devices. And you're only going to do that with a message broker architecture. And from that perspective, PubSub is the feature that addresses that particular point.
That's the killer app that you have for this. Okay.
Yes.
Do we have any other questions from the audience? Well, all right. Thank you very much for your presentation, Randy.
Thanks.